Hello, Chris Keyack here with Keyack Technology Solutions. In this video today, I'm going to showcase how to create this beautiful looking wire mesh. So that way it actually looks like wire mesh, and you can see that I actually click on it and it looks very close to what's actually going to be bought from the manufacturer. And I am going to be displaying and demonstrating this from the steel detailing perspective, not from the concrete perspective. So on the rebar tab in Tekla, there is a mesh object, but that is for reinforcement and using inside of cast units and concrete. And that is not what I'm going to be doing here. I'm going to be doing a wire mesh that you would buy, and you'd be using it, for instance, here in this decorative railing. Okay, so the first thing you got to understand is, what are you actually buying, right? So is it like pre-cut sheets where it's 4 foot by 4 foot, kind of like how grading and other things are bought? No, in this particular case, it's actually a long roll of this mesh that gets purchased, and you can specify the different widths that you want to start out with. And then they're going to unroll and lay that out there on the rail and attach that together with 2 pieces of wood. So partly I needed to figure out, how do I want to detail this and how do I actually want this in the model? And so you're going to see that the technique I'm using is actually going to allow it to be adjustable based on the final length that's needed for the rail, and it's going to be one long piece. Now, if I wanted this to be like just standard lengths and then just copy those standard lengths to whatever I need, then I would probably go the item route, which I'm also going to quickly demonstrate and show here in this video. But first, I needed to understand, what is it that these guys actually purchase, and then how do they fabricate it, and how do they want it to appear on any shop drawings or reports, and then how do they want it called out on the erection drawings. So this was key to first understand. Okay, to get started, I'm going to come up here to the steel menu, and I'm going to go to the beam command. When I double click on that, I'll go over to the properties on the right, and I actually have some save settings already created here called WC Wire Mesh. Now you'll see here that I've just called the name exactly what I want to show it on the bill of material. And I call that wireframe mesh 2 by 2, so for 2 inches by 2 inches. Then here I just entered in, it says the 16th, but I actually took the 14 gauge decimal value that I found for that on the product catalog online. And then I just typed in D for a round D parametric profile. So if I click on this, you'll see it's orange. And orange means that you can just type in whatever numbers you want there. Same thing like with plates and stuff. I could have done rod or whatever here, or AB or cable. But I just chose D because that's very simple. And then I put in the decimal inch value for that 14 gauge diameter of that particular round bar for the mesh. Now I probably needed to find a material grade, so I just kept it at A36 for now just to keep it simple, but I could have probably found the appropriate material grade for that, and it is galvanized, so I put that in the finish there. And then this is the piece marking that I want here, and assembly marks have the dash, and then part marks have just the letters. Okay, so to get started, I'm just going to get the first length of rod in there. And I'm just going to keep it simple, right? Like I just wanted something that I know is equally divisible by 2 inches, so I'll put in a 5 foot long rod. I'll right click and interrupt, and you'll see, there we go. There's that first bar. Now you'll see that the bar is going towards the far side. So depending on which way I want and how the roll will actually be unrolled, part of the bars are on one side and then the other on the other, right? So the vertical bars will be coming near side, and the far side bars might be going horizontal and far side. So what do I do for the vertical bars? Well, for that, what I would do is I'd come in here and I would pick like on the bottom, and then maybe I'll just go vertical here. And so I know that I'm going to buy a 4 foot wide sheet, so I'll just start with that. And then I'll put that piece in there, and then you'll see there is the piece. It's just really small, so I have to zoom in to actually see it. But you'll notice that they're both on the same side. Now you have to determine, how accurate do you want this to be placed? Do you want it to be like where when they are overlapping a little bit, it kind of perforates down and sort of bends the other backing bar? It just depends on how it looks. But if you want it to be super accurate, like that these are 2 separate bars welded to each other, then what you could do is you can just go ahead and switch this and change the position so that way it goes the other direction. Now, what am I doing next? The first simple thing is, if I was just trying to create like a 4 foot by 4 foot like sort of standard sheet, then I would probably just model this all out, and then I would create an item of it and call it a day. So let me actually do it that way, just so you can kind of see how that would work. If I take this piece here, I'm just going to window around it so the whole thing selects. I'll say copy special linear, and then I'll do 2 inch vertical. And if I take that, I think I'm going to need 23 copies, but let's see. Yep, so 24 copies, 24 copies gets me to that 2 inch spacing all the way to the top of that 4 foot wide mesh or 4 foot tall mesh. Then I'll take this and I'll just do the 2 inches in this direction in the X. So I'll zero out this number here, and I'll just say 24. And I actually did 5 foot there, so I need a little bit more. So let's just do 2 inches, and then I need another, I think 11 or 12. So let's just say copy, I did actually too many there. 2 inches divided by 12 is 6, so copied a little bit too much. I can do math, I promise. But there we go. We've got the initial outline of all the parts. Now the first step is that you would actually need to, if you want this to be like one single part, see how this is all separate parts? I don't want to weld these together because I don't really want this to be an assembly. I just want it to be a standard single part that's called out. So what I chose is that if I wanted to make an assembly drawing of this, I want this bottom piece to essentially be like the main part or the call out of that piece. And I want the shop drawing to go from left to right to follow like, you know, this horizontally. So I'd see the 5 feet as the length and the 4 feet as the height or the width, right? So what I can do is I can go to the edit tab here and I can go to added material. So I'm going to go ahead and say attach to part. And what this does is it fuses separate parts in the model together. So Tekla says select the part that you want to attach to. I'm going to pick this bottom part. Okay, now it says to go ahead and select all of the other parts that you want to attach to that. Now I want to grab all of these other bars and I just want to make sure I get them all. Yep, so I've got everything highlighted there. And then I'm just going to go ahead and middle mouse button and then right click and interrupt, and look at this. Now when I go back and I click on the part, it's all seen as one big part. That's what that part add does, is it fuses all those materials together. And you can even see sort of like these kind of outlines of the part add, because it basically takes like, without getting too deep into this, it's almost like an anti-cut. Cuts remove material, and part adds sort of add or fuse material and union those materials together to be considered one part. In the database, they are still separate objects though. So let me show you how do you get back to the separate objects, because you might actually accidentally pick on them when you're hovering over certain objects. But if you want a guaranteed way of clicking on them, if you go down here to your selections at the bottom, there's this ability to select cuts and add a material. So when you do that, now when I come back, look at this, I'm getting to the individual part adds that this did. And you can actually change and adjust those. And you can always come back in here and explode this so that way it goes back into separate parts and you can modify it. But when I go back to selecting parts, you'll see that if I click on any of those, it highlights the whole object and all those part adds as one object. So this is step one, right? Is to just join these two things together as one unified solid or part. Now the other thing I did here is I don't want this to be called D1/16 in the bill of material. So in the user-defined attributes, I actually came in here and I turned on the BOI or bought out item user-defined attribute, and I typed in WFM 2x2, and that's what's going to be actually in my bill of material on the shop drawings, as well as any of the Tekla part reports like the 350 material list and things like that, or the assembly bill of material list. They're going to use a rule that has an if-then statement in it that says if this is filled in, then this is what I'm going to show up. Now also even on the Tekla PowerFab side, so if I were exporting this all through the XML and the PFXT file exports for the export to Tekla PowerFab, it reads this spot out item attribute, and this is what the profile description would output. Now I could technically take this and I could copy it multiple times. So if I actually just came in here and just say, you know, copy linear, or just copy, and I went from here to here, I can just make a whole bunch of copy of those. So technically this is good enough. Like this is just fine how I did this, and you could stop the video here and go, okay, cool, that's how I did the mesh, and then you could add and remove bars and change lengths or do whatever you need to do manually, right? And this would actually bill out. Now the only thing that I would say about this particular step here is that it does leave a lot of extra like kind of weight in the model. If you think about it, this is all a bunch of individual parts and part adds, like kind of joining that together. So in the database and in the model, if you had like miles and miles of this or like tons of it, it does add a little bit more weight to the model. There's one other step that you can do. Now I intentionally modeled this down here near the origin and in the positive x-axis, so that way I could actually turn this into an item. Now, when you create items of objects that are created natively in Tekla and you don't say export them to an IFC file first, you have to strategically think about how you're putting that part in the model. And if you use a beam object, I usually do the part add to the object that I want the item to essentially align its picking points and its coordinate system to. So that's why I picked that bottom horizontal bar there. And it was also for the fact of trying to make a shop drawing of this, and it would draw it horizontally. But I just wanted you to understand that there's a couple different strategies to making items. The very simple, very easy one, but you don't have any control of the coordinate system and how it does it other than the source object that all the part adds were added to, is you could come up here to the edit menu and you could just go ahead and say create shape from geometry. Right? So the convert part to item, it does exactly the same thing, except it not only creates the shape item geometry, but it gets rid of these part adds in the model and this part, and it actually replaces it with the new shape item. So I'm simply just going to say create shape from geometry, so it leaves my source object alone. So I'm going to choose that, and it says pick on the piece, And then it says here at the lower left, a new shape has been created, and it's got underscore underscore WFM 2x2. Now, what did it do there if you look at the lower left-hand corner? If I actually put one of those suckers in, so if I go back to the steel menu here, and I'm going to go to item, and then I can come over here to the profile shape selection here. So if I click on that button, that'll open up the item tab. I'll go to ungrouped, and there is my new WFM 2x2. Now, the important thing is I wanted to make sure that it said solid here on the right-hand side. See in this panel where I'm hovering, solid is important. If you did an IFC export of this and then just kind of told it to import the shape directly from a created file like an IFC or a step file or something that you exported from Tekla or even SketchUp, the thing you have to watch out for is sometimes when you import things from other files versus natively converting them from within Tekla is it doesn't create a solid, true boundary representation around the entire object. And if it doesn't say solid, then the weight will not be calculated properly because the volume can't be calculated. So that's something important to watch out for. If you ever make items and you import them in from another CAD software and it says doesn't say solid here and it's giving you a 0 weight, that's something you have to watch out for. Now, the one thing I don't like that it did is it created this, but there's something about shape item creation in Tekla using the native geometry where it tries to read the grid location and the model. I don't know why it does this, but it does do that. And since there was no grids in my model, it puts this underscore underscore here. And there's unfortunately no way that I know of in Tekla in the interface itself to rename that. You can't come in here and you can't rename this or change it in any way. So how do you go fix that? Well, let me first get one of these in here. So I'll pick my start point, and then notice my second point. Looks like I didn't select the actual item. So let me go back and select that. So ungrouped, I'll select that one there, press OK, and modify. There we go. There's that shape item there. And so it puts it in there, and it follows the picking points of where the original beam object, so that part object down here in the bottom, that start and end point, it followed that when it created the shape item. And the second point here is just nothing other than an orientation or direction point. So look at this. You can come over here and you can manipulate some of the properties. So let me just modify this and just see if I can get this to be exactly how I wanted. Now look, here's some of the things I don't kind of like is it's doing offsets in a way that I don't really want. Like I do want this at top, but then I'm trying to, kind of mess with this. Let me just see what this does. So see, that just changes the left and right, and it's not exactly positioned where I wanted it. It's almost like it took the center of that when I kind of leave this all at middle. And I'm like, oh man, okay, there we go. Now it's back to the position. So the position properties didn't quite exactly 100% work how I expected, but let me switch this back to middle and see if that still keeps me there. Okay, great. So it keeps it centered thickness-wise on the bars, but now the material is going upward. So everything looks like fairly good to what I wanted. Okay. So now that I got that, you can see that I've got the shape, but the shape item name is not exactly what I want. So the only way to go fix that is if you open up the model folder and you go inside of your model folder, there's a shape geometries and a shapes folder. When you create a new shape item, just like I did that shape geometry, it creates a new file inside of your model folder. And you have to look at the latest date modified and time modified, and you'll see that there's one file there for the actual description of the shape itself, and then the shape geometry, like all the actual detailed information about it, is stored in another file. And there's one file for each. So you have to look at the date modified and the time, and you have to make sure you grab both the file in there and the geometries and copy that into the corresponding folder in your firm folder if you want to reuse this from job to job, or just copy those files from here into your model template that you're going to use for the future. Now let me just show you back in the shapes. I'm looking at the date modified, and I'm just going to open this up with, say, Notepad. And here I've got Visual Studio because I'm a programmer, but same concept. You'll just open this up, and underneath that name property there, you'll just get rid of the underscore or whatever grid name is in there, and you just save, close that. And then if we go back into Tekla and we just say, let's open the model again, it should reread from that XML file in that shapes folder. And then now it's going to properly name that. Instead of that underscore in there, it should have the proper name based on what we just changed. Okay, so then when I come back in there, we'll just go ahead and zoom in once the model loads up. And now it says WFM 2x2. So now look, if I wanted to still control the shape type for PowerFab and stuff like that, I may still want to come in here and fill out the bought out item. But now I don't have to necessarily do that. This will appear in the bill of material exactly with that name there, because that's what is considered its profile name. And then, so I don't have to do any special rules like with the bought out item if I don't want to. The other thing that's nice about this is much lighter weight than this part add over here on the left. Like even when I have it selected and I try to zoom in a little bit, my computer has to jump a little because it's like got a lot more objects selected than say this lighter weight. And items were intentionally designed to be sort of bought out items and things that don't really change in geometry or shape that much. Things like brackets or maybe even like a standard mesh panel or grading treads for stairs and things like that. So the item route is another great way, especially if you want to keep your model a little bit lighter weight. You can actually cut these. So you can use all of the polygon cuts and do copes and cut this down or cut skews in these if you want to. So the item route is really great if you're going to kind of cut special shapes from a starting point of wire mesh or perforated metal or grading and things like that. And it is lighter weight, but I didn't quite go this route for this customer because they actually wanted just one large piece across here. Now, in this case here, like you'll see that I actually just made copies, so I could have gone the item route, or I did it another way where I made a custom component and an API plugin that dynamically kind of arrays the number of bars and the part adds, so that way it can be stretched and adjusted on the fly. But I just wanted you to see that the item route is another good way to go as well. Okay, so how do I get that new shape item over into my firm folder or my model template? Well, there's the shape geometries and shapes folder. If you're going to use a firm folder like I have here on my left, then what I would do is I have a profile folder. So Profile with no E at the end. You have to make that subfolder. And then there's a shape geometries and shapes subfolder inside of there. So Tekla is expecting this profile folder first. You can't just have your shape geometries and shapes folder in the top level firm folder. Then what I would do is I'd go into shapes and I would find this current date modified of the latest file that was created and that I changed or modified. And I would make sure that that gets copied across over here into my shapes folder. So I would take the one that I had modified. Let me just double click on this and make sure that it's the right one because these two dates seem the same. So WFM 2x2, that looks actually really good. That's the one that I want. So I'm going to take that, I'm going to say copy, and I'm going to go in the shapes folder here, and then I'll paste it over into that shapes folder in the firm folder. Then I'll go to shapes geometry here in my model folder. Again, I'll look at the date and times of the files that were modified, and I'm going to take this geometry file that was just created here, and I'm going to go ahead and say copy, and then I'll paste that inside of the shape geometries folder, and now that shape is available for me to use on other jobs. And I could also have done the same thing and just copying those respective files into a model template if that's the route that you go. But either way, I just wanted you to see that if you do the firm folder, you have to have that special subfolder profile first, and then you have to get both the shape and the shape geometry file. Okay, so then I went another route here of how could I make this parametric? So first I made a custom component, and I actually made it parametric where you can change some of the values, and I wanted you to see how that works. If I just pick 2 points here, it's going to read the distance between those points and the length formed by that, and then it's going to use these input values, and it's going to use an array macro inside of that custom component to try to put that in there. Now you'll see that it took quite a few seconds for it to do that, so it's a little bit slower. So I did both a custom component, and then I also did a programmed plugin with the Tekla API. So sometimes I will use custom components wherever possible, right? The great thing about custom components is it doesn't require programming. So I can teach a user how to do this, like if they're pretty sharp and they can do some if-then statements, kind of like doing things with Excel, then I can pretty much teach you how to do certain things, even parametric things inside of custom components, and it doesn't require coding. It just requires a little bit of understanding of logic and how Tekla works. Now, sometimes though, due to speed or complexity, custom components just aren't always the best tool, and so then I'll actually go through and I'll use programming and the API to make a parametric plugin, and that's what I did here. So ultimately, same functionality, but if I come in here and put this in here, like it is going to be a lot faster, like 2 seconds to put in like that even longer version of that, because the array macro and everything in the part add that's being done over here is much slower than me doing it in the API. But ultimately I get the same result. Now what I'm going to do, what's great about this is that if I do stretch this, right? So if I just take this point here, the user has full flexibility of how long they want to make this. So, I was trying to make it very easy that if the user doesn't care about a drawing, they just care about a lineal footage report of how much they need to buy and how many rolls they need, then they could have actually just picked along that entire rail there, because it's not like these rail pieces are prefabricated. They actually prefabricate and cut the posts and put those up, but then they just unroll this out in the field and cut it up wherever they need to once they get to the end of a roll on a straight run, or if they get to a miter and a transition from one leg to the other. But so that's why I had to know what it is the user wants and what is the end product that they care about and the flexibility that they're looking at to see whether this part add route, like the first way I did it, makes sense, or if doing it as a item and they start with standard like panels and sheets that they then copy and cut from, or do I need to make something that's parametric that can change in length and is custom components or the API the best route to go? So that's partly why I'm making this video too, is it's not just the understanding the technicals of how to do stuff in Tekla. There's sometimes many different ways to do stuff in Tekla, but you have to understand and start with the end in mind. What's the end product or end result that you care about in order to figure out what's the best way to design about how to go about doing it in Tekla. Okay, so I'll end the video with explaining a little bit how did I do it. I'm not going to build the whole component, but I will edit this custom component so you can see how did I make this thing parametric, where when I change the endpoint here that the whole component and the number of bars and everything react without having to do it with programming. So if I edit the custom component, it'll give me 4 views here, and then it opens up a custom component editor toolbar, and then I've got the browser that shows me all of the objects created by that. Now, if I actually go in here, you're going to see that there's the original part that I did, which is going to be that horizontal bar on the bottom. And you'll see that there's these little like magenta or pink bow ties in the model. And what that is those are bindings, or like essentially gluing this point to specific planes in the model. So what that means is when I picked and defined this custom component part, basically it creates planes in 3 directions, like an XYZ type plane locally formed by the 2 picking points that I picked to put that custom component in. And then for that horizontal bar piece, that original part here, so that first horizontal part, which is what I'm selecting here, I actually bound the start point. So I right clicked and said bind to plane. And when you see that, if I come up here to component planes, look at this. There's those planes I was talking about. So you can see that you can bind it in 3 different directions and essentially glue the start point of that beam to the first point picked. And then the second point can be bound to the second point picked. There's that end plane there, right? For the second point for the component. So I bound that so that way that source bar is going to always be there. And then I also modeled in a vertical bar here, and I did the same thing. You'll see that the start and end points are also bound to those planes. So that way my starting bars that I then did like a kind of like a part add from, I then arrayed those using this array macro. So that's what you'll see here. You'll see that here's the original part, which is the horizontal bar. Then I did a part add for the second bar right above that. Then I did a part add for this vertical bar. That's what these added materials are in the browser. And then I did an array component of those part adds to make this parametric to automatically array the number of part add bars that it needs horizontally and vertically to make this a parametric basically component. So that was the secret. So what does this component mean, this array component I keep talking about? Well, if I search for array here, there's the old school way of doing it. This is how we used to do it with custom components. This is a little bit slower and not quite as flexible as the line array tool. But this plugin here lets you do basically like kind of a copy array of objects in an X, Y, Z direction. Like you can do a crazy amount, and I think even like a polar or an array one here using this array copy tool. So this is the one that I actually use, and I actually embedded that here. So I'm just arraying that part add that I did here horizontally and then the vertical part add. And then it just basically, you have to just do some formulas here in the variables list. And that's what I've done is I just came in here and I did some calculation based on the distance of the start length, from the end point picked to the start point picked, calculate that length. And that's what this point to point here is, this distance here. So let me actually show you that. When I click on that dimension here in the variables list, it actually highlights that in the model. And this is a neat little trick. A lot of people don't know this. Well, what did I do? I know that I took that horizontal bar, that source beam bar, and I took its endpoint and I bound it to this end component plane, right? So that means that that bar is always going to be at that end plane there, wherever the second point picked is that the user puts the component in the model. But the next thing I did is I took that point there, and this is what people don't know commonly about, is that there's a create reference distance. And I then did a binding back here to the first point picked plane, and that then returns a variable that you can use, which there it is. There's my point-to-point variable. It's that reference distance there. And then I took that total distance between the start and the end point, and I just start doing a whole bunch of formulas in here to calculate the number of basically bars that are required over that distance. And then I tell the array macro how many times that I'm going to do that. So watch this. You can look in here if I go underneath my component, and then I go under the properties. These are all the properties in here that are inside of that array macros dialog box. So see these fields here, all of the inputs, they have variable names underneath them. And I took the formulas that I calculated in my variables list at the top level here, and those spacing for number of horizontal bars and number of vertical bars, I basically just mapped those by right-clicking and saying add equation, and then I just set those variables in that array component to basically be the values and variables from my dialog box and what I calculated. So this is basically how I could make it parametric. Now it's a little bit programmy, right? Like there's logic here, but it's no more complicated than doing things, say, in Excel. So, just with a little bit of understanding and logic and training and learning how to basically connect this variables list, which whenever you see me train this or talk about this in my videos and custom components, the variables list here, that's what I call the brains, right? This is the brains, and in the component browsers, the body. This has got all of the objects like your limbs, your arms, and your legs, everything that is made up in that custom component. And your brains send messages, through nerve signals, through your spinal cord and everything into the body, right? So that's what this mapping and adding equations does, is it takes formulas and things and logic that you're doing in the brains and the variables list, and you're linking that here to specific properties to give instructions to the body and tell it what to do. So I just wanted you to see that. I'm not going to go through the coding side, but I still wanted to show that I did something with the API, because the API will perform a little bit faster sometimes and can get me through certain levels of complexity that I can't always achieve very easily in custom components. I've seen some guys in the world who do really amazing things. One guy, probably the best guy in the world who does custom components, is Dave Mitchell over in Europe, and he just makes custom components where I'm like, I'm going to give up and I'm just going to do that with the API. So things, almost anything can be done pretty well with custom components, but then you just have to look at the complexity. How hard is it to manage? How much time are you spending? How slow does the component become once you start putting a lot of arrays and nested components in there? And then that's when it makes sense to sometimes go with the API. Well, either way, this turned into a wire mesh training session, into more of a little bit of a philosophy and logic of how to set up Tekla and how to think about the different types of tools and the appropriate thing. Do I just quickly get something in, part at it, and use the bot.item UDA and call it a day? Do I go ahead and make it lighter weight and turn it into a shape item that I need to cut and copy and use later? Do I need it to be parametric, and so will I make it a parametric custom component with bindings and an array of objects? Or do I need really the ultimate level of flexibility but yet parametric power, and I'll customize and program something with the API?